All right, ladies and gentlemen, hang on to your hats. This is Logarithmic Graphs, and just look at the killer that we get to go ahead and try and graph. And here's the thing, no graphing calculators allowed. What are you going to do? All right, so let me go through a process and show you just actually, as scary as this might look, it's not scary at all if we approach it very systematically. Okay, so the first thing I'm going to do, like any function, is I'm going to move stuff around into the implicit form. And then I can analyze what changes have happened to the graph. And then it becomes actually a pretty easy question. So let's take this 1 and move it over to the other side. Okay, so that's where we're starting. Alrighty. Looks pretty good. Then, we got a 2 in front of the x inside of the function here. I better factor that 2 out. So this would be an x plus 2 in the brackets. All right. Now, this negative 2 that's sitting out in front, I'm going to divide that over to the other side. So it's going to be a negative 1/2 sitting in front of the y minus 1 in brackets. Well, look at that. I think we are well on our way to figuring out what makes this graph change. So, all right, there we have it. Now, let's figure out the changes to x and the changes to y, and then we're going to get some nice basic points, put it all together, and we are laughing. So, what are we doing to x? Reciprocal of 2, so I'm going to have to multiply by a positive 1/2. And then what do we have happening in the brackets? Looks like we want minus 2. So a shift 2 to the left. And then for y, the reciprocal of this guy, multiplying by negative 2. And then we want to add 1. So that's going to move the graph up by 1. Alrighty, so let's get some really good old points. Now, when we say old points, which function are we talking about? Well, if you take out all the extras, we're really talking about this guy here. Y equals log of x base 3. That's our sort of bare bones function. That's what we're trying to adapt here. And a really good way to analyze the original old function here is to rewrite it as 3 to the y equals x. It's much easier to figure out the points and how they're related in this form rather than as a logarithmic statement. So let's get some of these old points, put them in a table of values. See what kind of points we're talking about. Well, just a tip. It's easier to sort of plug in the y's and then figure out the x's rather than figure out x and then figure out y. You'll see what I'm talking about. Like, how about negative 1 as a y value? Then 3 to the negative 1 would be our x value. And 3 to the negative 1 is like 1/3. And how about 0? 3 to the 0 would give us x would have to be 1. And then how about 1? 3 to the 1, well, x would have to be 3. And finally, how about a 2? 3 squared would equal 9. So these are my old points. Now what I'm going to do, and I think I'll put them over here on the sidelines, because then when I I should be able to do it here. Here's where my new points are going to be. Okay. And there's one more thing that I'm going to put in there that might be really important, but we'll get to that in a little while. Okay, so let's see here. Let's change the x's, I guess, first. I got times by 1/2. So if I times 1/3 by 1/2, that gives me 1/6. And then I got a minus 2 from it. So I got 1/6, and I'm going to subtract 2, so that'll give me negative 1 5/6. You can certainly change that to a decimal if you prefer. How about 1? 1 times a half is a half, and then if you subtract 2 from it, you'd get negative 1 and a half. And let's go to the 3. 3 times a half would be like 1.5, and then we're going to subtract 2 from that. So negative 1 half. And lastly, where are we? 9 times a half is 4 and a half, and take away 2 leaves me with 2 and a half. Well, those are a bit messy with all the fractions, but these other y values should be easy. Times by negative 2, so negative 1 times negative 2 is 2, plus 1 is 3. Okay. Times by 0 is still 0, and then we add 1, so that's 1. 1 times negative 2 is negative 2, plus 1 is negative 1. And then 2 times negative 2 is negative 4, plus 1 is negative 3. So I think I've got all my points, but there's one more thing that I think would be a really smart idea. Remember there was one asymptote with logarithmic graphs, and it was the y-axis itself, which we would call x equals 0. It's just that vertical line, which is the y-axis. Well, where's that guy going to go to? What are we doing to x? We're moving everything to the left. So that guy, just so we know, is at x equals negative 2. And it kind of gives us a little bit of a framework. All right, so I'm going to clear off all this stuff on the left side here, and then plop in a grid and see if we can graph this thing, make some sense of it. Okay, so let's see what we can do. So we have, let's put in this little vertical asymptote. It is over here at x equals negative 2. All right, there it is, more or less. Gives us a guide. And then we've got our points here. So we've got negative 1 and 5/6 is up at 3. So kind of like right about there. And then we've got negative 1 and a half is up at 1. And we've got negative a half is at negative 1. And then we have 2 and a half is down at negative 3. So what do we have happening here? Okay, what I think the normally this graph, it would have gone up here like this. You know, if you follow my little pen here, it would have gone up like this and then turned up that way. But remember, when we did some flipping here, specifically with the y value, this whole thing got flipped over. So this seems to be heading up towards the, snuggling up to that vertical asymptote. And then we have this guy carrying on down here. And then got to get to that point down here. So I think this is just going to come roaring along like that. If we were asked for some specifics like domain, it'd be easy to spot from the graph that x is greater than negative 2. As for range, it looks like it's all numbers, okay, as we would have expected. And I think that's it for specifics on this particular graph. So there it is without a graphic calculator. Not too bad, I dare say, and very doable. So that's where we're going to stop.